Welcome to Ideas at Work, a podcast featuring conversations with scientists, academics, writers, and thinkers who are influencing our time. I believe the world has changed, and those ideas we once thought to be true will now be viewed through an entirely different lens post-COVID-19. What I'm interested in discussing is the emergence of a new normal. What changes, what stays the same, and what slips into the annals of history. Most importantly, my viewpoint is anchored in two things. One, organizations. What's the role of the company in these new and turbulent times? And secondly, what are the main ideas we need to consider or reconsider? Today, I'll be chatting with David Krakauer. David is the president of the Santa Fe Institute, where his research focuses on the evolutionary history of information processing mechanisms, both in biology and culture. This includes genetic, neural, linguistic, and cultural mechanisms. Typical of the Santa Fe Institute, his research is seeking analogous patterns and principles spanning multiple levels of organizations, including genetics, cells, organisms, and whole societies. Dr. Krakauer received his doctorate in philosophy and evolutionary theory from Oxford University. He remained at Oxford and was named a Wellcome Research Fellow and a lecturer at Pembroke College. He then accepted an appointment to the Institute of Advanced Study in Princeton. David also served as the director for the Wisconsin Institute for Discovery. And in 2012, Krakauer was included in the Wired magazine Smart List as one of the 50 people who will change the world. You should know, David's ideas are brazenly cross-disciplinary. The big question that David asks, what is intelligence? And as importantly, its corollary concept, stupidity, has huge implications on how we see science, philosophy, and the nature of the organizations that we all belong to. I suspect after COVID-19, there'll be a great sorting, a sort of dividing line, BC and AD, if you will. And some ideas and thus some organizations will wither and others will prosper. As organizational people, and I believe we all are, we need to ask ourselves why. Are there ideas that can make sense of these strange collectives of humans we call organizations? Well, we have no better guide than the maverick scientist leader of SFI, David Krakauer. David, welcome to Ideas at Work.
Thank you, Toby. Looking forward to it.
Yeah, good. So first off, you sit atop the perch of this place called the Santa Fe Institute. Can you tell us just a little bit about what the Santa Fe Institute is?
Yeah, so the Santa Fe Institute describes itself as the global headquarters of complexity science, right? Where described by others in different terms, where Rolling Stone magazine, I think, described us as the Justice League for Renegade Geeks, and so on. So the history of the Institute is bound to the history of the Manhattan Project. We are in Santa Fe, New Mexico, on a mountain. And in the 1980s, a number of scientists involved with Los Alamos became very interested in applying very rigorous frameworks and methods to very difficult problems, problems outside of physics. The history of the Southwest, archaeology, the workings of the brain, human behavior, society at large, to include cities and so on and so forth.
Yeah. And
a sort of field that we call collectively complexity. That is the study of adaptive systems.
Right. Yeah.
Right. And physicists, as you know, don't study adaptive systems. They study electrons and quarks and condensed matter and so on. They were asking the question, could you be as successful at generating big theories, like the theories of Maxwell or Einstein or etc., but in this domain of adaptive phenomena? And that's what we do. We've been doing it since 1984. And we've been variously successful and unsuccessful. And perhaps we can discuss some of that.
Yeah, right. And so some of these founders, as you alluded to, were quite influential in their field. So Murray Gell-Mann winning the Nobel for discovery of the quark. Other Nobel laureates,
Canavan. One of the interesting things early on was, and this was a little surprising, I think, for an institute that likes to think of itself as somewhat maverick, and I think it is that the founders were establishment. Right. In other words, so the key figures here, Murray Gell-Mann, Nobel Prize in Physics, Phil Anderson, Nobel Prize in Physics, Canavan, Nobel Prize in Economics, and so on, these were people who were at the pinnacle of their career, highly respected.
Yes.
But I think they were sort of closet adolescent mavericks. I think that they had been very successful. They were very smart and very deep, but they wanted more. And someone like Murray, for example, as you know, he always wanted to be an Indiana Jones style archaeologist. That was his dream. It just turned out he was a bit too good at math and physics. And it was easier to, essentially, I mean, to be honest, it's simpler to be accomplished in those fields. So I think this was a sort of a late life desire to confront problems that they had been fascinated with in their childhood, actually. And so that's surprising to many people. You mentioned companies and organizations. I think most people would think that if you want to build something really crazy and radical, you should start with crazies and radicals.
Right.
But we didn't.
Right.
And in fact, we had a very different development. We started with sort of these unimpeachable, extraordinarily gifted leaders of their respective fields. And they then attracted the radicals and mavericks, and they gave them a kind of umbrella protection by virtue of their status to pursue really crazy ideas. If they had founded the Institute, it would have failed.
Interesting. Yeah, interesting. So a couple of things to unpack there. I'd like to just dig into a few things. So one of them was, you mentioned that they were deep. And in my reading of the founders, my observation is, obviously they're deep, but my other observation is that they're broad.
Yeah.
They had broader interests than what you would typically think a Nobel laureate would have.
Well, but that's interesting because that turns out to be a myth. And in fact, there's a book that I was recently reading called Range. I don't know if you saw that book, written by Epstein.
Oh, yeah.
He's the guy who wrote The Sports Gene.
Yeah.
And it's quite a nice book.
Oh,
but
yes.
One of the things that he talks about in that book that I didn't know was that, in fact, one of the characteristics of Nobelists is their breadth, because one tends to assume that they would be representative samples of the community in which they work, but they're not. They typically have a lot of breadth. As you point out, our founders were unbelievable. And, Phil Anderson, one of them who just died, who worked in condensed matter, was actually, I think, the fourth best Go player in the world for a while. Yeah. And when I met with him, all he wanted to discuss was literature, not science. So I think you're absolutely right. In fact, that's one of the tests that I use when I'm talking to people coming to SFI, which is, I sort of know what their science is. What I want to know is what they're reading, what they're listening to, what their broader interests are.
And that's not just because you're interested in acceptance, it's because you actually think that creativity happens with adjacent ideas and adjacent fields. Is that correct?
I think that's true. I think it sort of depends what you do. And in complexity science, the game is connecting domains of knowledge, connecting methods, much closer to mathematics. And in that sense, we're not very disciplinary. And having the appropriate sort of S-shell orbital electrons so that you can bind with lots of other elements in the periodic table to build interesting molecules is our game.
Right.
And so we're a bit like a hydrogen atom. We're kind of tiny, we have one electron, we bind to lots of stuff. And whereas I think most departments are these big, rather inert, heavy elements that are very deep and potentially can produce a lot of energy, but they don't interact with much.
Well, I'd love to jump into a conversation about science, philosophy, reduction, and complexity. But maybe before we go there, you can define for me what complexity is. One of the observations I've had at SFI is complexity is spoken about, but there seems to be everyone seems to be loath to define it.
Yeah.
It's often, I think it's Justice Potter Stewart, in his famous description of pornography. He knows it when he sees it.
Yeah.
Is it a tell that complexity seems to be so difficult to describe, or Or how would you describe it?
Yeah, we've talked about this, Toby, and I don't feel this way. I think that, I mean, if one was being fair, you'd ask a physicist how you define physics, and they'd get all flummoxed, right? Because they couldn't. And in fact, it's quite interesting. I have asked that question many times when people ask that question of me, right? Because they want to put me on the spot and show that our field is embryonic, whereas theirs is mature. And they say, okay, what's your field then? And most can't answer the question, by the way. You should do the experiment. But the best answer I get, and the most common answer I get from physicists, is we do back of the envelope calculations. Right, so they work in the postal service, right? So it doesn't really tell you much about physics. So, okay, with that caveat in mind, I think you can define a field in different ways. One of the ways you do it is by domain. That's typically what people say. Biology studies living things, right? Physicists study non-living things, which are either very small or very big, and chemists study non-living things that are kind of in the middle, that sort of thing. So by domain, we study adaptive systems, right? And so that could be an economy, it could be a brain, it could be a human society. They all adapt. And that's the biggest, I guess, integrative factor. But then you have to develop methods that are appropriate for the domain. And so that's the other way in which you define a field, right? And I think that, so we've been developing over 30 years, and many other people too, tools and frameworks that work when you're studying adaptive systems, and you're not trying to sort of shoehorn a complex phenomena into a very simple box, which happens a lot, right? You use the tools you have, and we'll get there, reductionism being kind of easy, and so people use those methods all the time. So the methods of scaling theory, of adaptive dynamics, of network theory, of agent-based models, of genetic algorithms, and all the things that over the years we've been producing in order to address that domain. And then there are these much deeper, formal ways of thinking about it, which of course interest us here. And that has to do with the fact that when you try to use these methods on the domain of adaptive systems, you produce a very different kind of theory, and it doesn't look like a theory in physics. And some people would say it looks like a computer program, right? I don't think that's true. Or it can look like a very lengthy physical theory, like the Standard Model, but it very rarely looks like F equals ma. And so we call that the description length, or the Kolmogorov complexity, which is that as the adaptive system grows, the theory grows. And that doesn't happen in physics.
Okay, so I was asking you, David, that my intuition is that organizations are complex entities, and that we have this reductionist bias to describe organizations by their composite parts, which we murder to dissect, and so we don't really understand what an organization is by understanding its components. Help me out. Am I on the right track here?
Yeah, I think so. I mean, you gain some understanding, but it's not like a car. I mean, it's quite complicated, this. So if you take a mechanical object, so a non-adaptive object that we built, there is certainly understanding that comes from pulling them apart, a watch or a car. But even a device as simple as a clock or a car, that's not enough. And I can name the parts of a watch, but I can't assemble one. So some of these elements of the limits of reductionism even appear in the classical domain. Now, when you get to a biological system, if you pull apart the brain, you would learn almost nothing. In other words, if I showed you what was in my brain, it would just be a bunch of little cells, much less informative than pulling apart a clock. And that's interesting in itself, that the function is not built into the form in an obvious way. So that's the first point to make. The second point, which is really alluding to, is that many of the properties that we care about arise out of the collective behavior of a multiplicity of parts.
Right.
In many cases, the parts are identical, right? In the brain, for example, we have almost 100 billion neurons, more or less identical, and yet you can do Mozart and the Beatles and so on. And so those kinds of systems need to be understood in slightly different terms. And you need a theory of collective dynamics.
Right.
And that isn't reductionism.
Right. Is there a useful distinction between the complicated, the simple, and the complex?
Yes, there is. And this is quite well accepted distinction, I think. Simple, less, we'll get to simple in a minute, but certainly the complicated and complex. So the way that we would describe complicated is the rules that the system follows are quite parsimonious, but there can be many, many parts.
Right.
So think about a solar system or the universe.
Right.
The mathematics that you use in your simulation of the universe is quite simple. I mean, let's assume you're dealing with the right range of masses, so you can use classical equations. The number of equations doesn't increase because you increase the size of your simulation, you just have more parts and it slows down. That's complicated.
Right.
So many, many interacting components, but where the description of the fundamental principles is quite short. Complex is the opposite. Complex is, as it grows, you have to have more and more theory.
Right.
And there's a clue about that difference because we can put people on the moon or send people up in rocket ships to the ISS, as we just did, quite reliably. But I can't cure a cold, COVID-19. And how is it that a tiny little nanoparticle, a virus, just a few little genes, can completely take a society down, whereas it's kind of effortless for us to predict when the sun will come to an end, right? Or build a supercomputer. There's a clue right there. It's the same human mind, same human ingenuity, but in one case, it has no idea what to do. And in the other case, we're extraordinarily intellectually dexterous.
Now, when you say in complexity we need more and more theory, is that just the current state of our understanding? And do you think we'll reach a state where we'll have theories as parsimonious as there are in physics?
No, I don't think so. I actually think that is a characteristic of complexity. You talk to Jeffrey, one path that moves you in the physics direction is coarse graining, averaging.
Right.
And if you deal with average quantities, you can come up with F equals MA-like statements, as Jeffrey and his colleagues have, right? And it's the scaling of city size and patent production or metabolic rate and mass. So very simple equations which deal with average properties. But if you go to a higher level of precision, say to the level of neural circuits or the internal structure of a company, then the heterogeneity matters. So Toby, you matter in your company. You're not just another cog, and neither is anyone who works in your company. And I think that at that level, if you're engineering as opposed to describing, then the theory grows as the system gets larger.
Are you familiar with this? There's a management consultant, and he has a heuristic about, his name's Dave Snowden. He has a heuristic about complicated, complex, simple, chaotic, called the Canavan Quadrant. Do you know this at all? Or?
I mean, someone might have mentioned it to me, and I might have forgotten with great alacrity.
Yes.
So, to remind me.
No, it just builds an idea space where you can have some idea of how to operate in, if you think you're in a simple environment versus a complicated one. I just didn't know if you had been exposed to it.
Yeah, I tend to find, I have been asked similar questions, and I tend to find these, I don't know, so to be fair, perhaps he's understood. But complexity is sufficiently nascent a field and sufficiently difficult that some of these near bromide insights into how to navigate in a complex world strike me as maybe premature or wishful thinking or marketing.
Yeah. I don't disagree, but at some point, those of us who are pragmatic and in the world probably need some shorthand for, how to operate.
Yeah, but that's a very interesting point. And I would say, and this is where I think human beings, by virtue of navigating in complex worlds, have developed quite good intuitions. And we've also developed pathological ones.
Right.
But I find often, and I mean, it might seem a little odd coming from me, but the more sort of earthy, intuitive appreciation for how things work, often vastly more compelling than some simplified theory of a management consultant, right? And so it's sort of odd that at the either end is where I like to live, right? Give me people of great judgment and a certain kind of modesty in understanding the limits of their experience, or give me the other one, which is the kind of modesty of the difficulty of deriving a theory that works. And I often find that kind of intermediate space a little underwhelming.
Right. Now, if you were to put these on poles in a continuum, is one science and the other the arts? Is that what you're saying, or are you saying something else?
I don't know. Oh, that's an interesting question. I don't think I'm saying that, because I think artists develop very rigorous approaches to representing reality, and as rigorous as scientists. I'm talking about the value of experience, I think. And if you live honestly, right? In other words, and knowing the difference between an approximate theory that recognizes its own limitations and its temporality, and a kind of assertion of excessive confidence that doesn't have a good empirical foundation. I tend to get a little bit, I get a rash when I listen to that kind of idea.
If you're going to brag, you better have the math to back it up.
Or something, right? Or something, have the experience, right? Have the, in your life, there is such a thing as wisdom, or have the rigors. Yes, absolutely. I think both of those for me are compelling.
You just mentioned in passing COVID and how it flummoxes us. But, I started this introduction by saying that there will be a sort of BC-AD dividing line, and that this could be an epoch-making event. Do you agree with that?
Yeah, it could be. It could be. It should be, right? I think that's odd. Here's the thing, I feel more confident in saying it should be than it will be. And I'm wondering why I say that. And I think it has to do with the resilience of the institutions that have led to the crisis, in part, right? Because, as everyone knows, the crisis is a complex crisis because so much is entangled in it. We're seeing it as we speak in the streets of the major cities of the world. I mean, this is all related. And this exasperation with the state of the world, and the COVID was a laser beam that was shone on those weaknesses. And it is an opportunity for us to do something, I think. But I'm a little concerned that our memories are too short.
What about our tools? So maybe this can be a segue into reductionism versus complexity. You mentioned that here we are in the midst of COVID, a couple of months now, economic slowdown, what looks like almost in many parts of the US at least, complete civil unrest, so a tearing of the social fabric, what looks like a tearing of the sort of cultural deal that we have with one another, with what a leader is and how people should react, and so a deep disquiet with what's going on. And as you say, all of these things completely entangled with one another. Do you feel like complexity can be a tool to at least unravel for a second this entanglement and begin to see
very much so. I think that it already is in some sense. It's quite interesting that there's this interesting fact that methods diffuse first. Right? Most people like methods because they can use them. Right? In other words, ideas, frameworks diffuse slowly. And I think understanding that's important in this crisis, because the idea that we're describing, Toby, right, is the entanglement of complex systems and the limits of reductionism. That you don't fix inequality with one check, right? But that's difficult. To understand that you're beholden to the Amazon is difficult, right? Etc. On the other hand, you can produce this theory called network science. Right? And network science is used all the time now, in particular in modeling epidemics. You can produce agent-based models, which are how we model the spread of disease in cities. So there are methodological contributions of our science and others that are in use today that go beyond the models that we had 10, 20 years ago, and they're useful. So it already is true. But I think the question you're asking, which I think is more important actually, is we have to rethink society. We have to rethink the fact that it is actually, in some sense, irreducible. And that taking it apart into sort of simple causal elements and remedies that treat it in those terms are bound to fail. And I think that's the bigger thing that people should understand. And I think there are many beautiful case studies of that. And we have been trying to provide, I think scaling that you talked about with Jeffrey is a good example. I think adaptive dynamics is a good example. So in other words, there are these frameworks that aren't taught that would give people an intuition for how here I am, David, in Santa Fe, New Mexico, depend on someone in sub-Saharan Africa and all the networks that connect us. And the flow of goods and services and the kinds of governance required to manage that kind of distributed system is not taught, and we barely understand.
Right, and can we blame all that on reductionism, or is there, I mean, we also have a type of binary thinking, a sort of Manichaean us and them, a black and white. Can we blame that on reductionism, or is that just another cognitive bias we have? Like it's hard to see, more than two sides and pick a side.
Yeah, I think.
Or am I conflating too many things?
Well, no, I don't think so. I think that when I think about reductionism, I think about it in many different ways. Right. One of them is the illusion that you can understand the whole by understanding the parts. And that's even false with water. Okay. You can stare at an H2O molecule until the cows come home and not understand the transition from laminar to chaotic flow in your tap. Okay. So, and it's worse when it comes to adaptive systems. So that's one kind of reductionism. And already we know it's very limited. Another kind of reductionism has to do with causality, which is this obsession with monocause, which is if you just fix this one thing, everything will be okay. And hence this obsession with one-dimensional quantities in the field that I work on, intelligence, the IQ, this, the monetary value of a thing, right, etc. The interest rate, as if GDP, and you can just multiply them. We love those things.
Right.
And that's not ontological reductionism, it's epistemological reductionism. It's saying I can understand things by looking at one dominant factor, and that's false for many of the things we care about. And then there's the kind of pernicious disciplinary reductionism, which we see now all the time, which is, for example, I want to understand human behavior. Neuroscience can tell you why. In other words, good leaders have serotonin in abundance, or whatever, you name it. This kind of rubbish. And that's a different kind of reductionism, and it doesn't respect.
I've been boosting my serotonin. Not?
You do not need to boost your testosterone, let me just say. And so this is a very different kind, and it says that there are preferred levels of explanation, and that higher levels don't count, and which is absurd. It would be like saying, as we've discussed before, a mathematical theorem to be true would have to be presented in biochemical terms, which is obviously silly.
Do you think we have our civilization is at a stage epistemically where we're still suffering from a type of physics envy, that we still wish for causality and a simple explanation because it has been so effective in some fields? Do you think?
Absolutely true. There's just no doubt it's true. And that is the persistent allure of the simple.
Right.
I mean, it is extraordinary, right? I mean, Newton in the 17th century is living with his mother because there's a plague. He's dawdling about under an apple tree, and he works out how to essentially land a lander on the moon, right? The universal theory of gravity. And that's just so awesome. Right? Why can't I do that with, my relationships or something, So I think that it's obvious why it's so attractive. It's just false.
And we should say it has been very effective in its domain.
Very effective in its domain.
Yes. Yeah. Interesting. Okay, so your area of expertise is intelligence and stupidity. And so you talked just briefly about IQ, and I've never talked to you about this, but many people think generalized IQ is the predictive element psychologically of so many things that we find important. Do you believe that to be true, or are we being myopic?
Oh, we're definitely being myopic, and I don't believe it to be true. So I believe it to be false. Okay. So, well, there are different ways of getting at this. And I should explain for those who don't know. So I work on the evolution of intelligence and stupidity, which means I'm interested in many species that are not human. In fact, I hate to point out to people, most species are not human, right? So if you have this Darwinian worldview and you're interested in plants and oak trees and bacteria and cephalopods and cats and dogs, then the IQ test is less than useless because they can't take it. Okay, so I want to know where intelligence came from, and that means I have to look at qualities that all species possess in different degrees. And answer why they increase or decrease and so on. So that's the first point I want to make. It's useless if you're interested in anything that isn't human, okay, including machines, by the way. Okay. So the second point is that it's useful, but in ways that might be surprising. So, for example, the monetary value of an art piece is informative, right? But it doesn't tell you anything about the art piece. I mean, if I said, there's this painting, it's called the Mona Lisa, and you said, tell me about it. I said, well, it's priceless. You said, thanks, David. I'll be able to recognize it next time I go to the Louvre. And so that's the sense in which I don't like IQ. It's so coarse-grained, even though, and we can get at what it's saying, it is saying something about the object, which has something to do with its market value, but in a different market in this case. But it's not telling you anything about the fine-grained details that you actually care about as an art lover. Right. So as an intelligence lover, I find the IQ too crude because it tells me nothing about how you move, how you sing, right? How you think, your style. they're gone, right? And I mean, imagine you hired someone, you just said, just give me your IQ. I mean, and you were hiring one person to be a tennis player and the other person to be an opera singer. It would not help you. So that's the second point. So what is it? Well, we now know what it is. It's essentially correlated with working memory. And working memory is really useful in tons of areas, in solving mathematical equations, in playing chess well, and so on and so forth, in rotating objects in your mind's eye. And so many different tests are correlated in their results. And that correlation is essentially described as an IQ. And so it's not uninteresting,
Right.
but it's not finally resolved enough to be of interest to me.
Okay. You seem to insinuate, maybe I was following you incorrectly, that potentially every living thing has an intelligence. Is that where you were going?
Oh, absolutely, they do. Yeah. So I should define my terms. So without going into details, and I can say it very simply, intelligence is the use of rules that make hard problems easy problems. Stupidity is the use of rules that makes easy problems hard problems. And everyone knows this already. It's kind of funny. I always tell the story, when we were at school, the person next to you is so much better than you at something.
That you a lot, David?
Better than you. Let's say at algebra. Let's just make something up, or music, and the ultimate compliment you could ever pay that person was, "You make that look so easy." Right. That's because they did make it easy. And the ultimate insult you can pay someone is, if they're dealing with an easy problem, you say, "God, you make that look so hard," right? You're basically saying you're stupid. That is what you're saying, technically. And ignorance is just insufficient data. So it's different from stupidity, and it's different from intelligence, because it's just that the algorithm doesn't have enough data to use to find the solution. So you can't fault someone for ignorance. So if you think about it in those terms, it has a kind of beauty, and you can formalize it mathematically, that it's function dependent, right? So if you're a bacterium swimming around in some soup of nutrient, are you using the rule that will get you to your target quickly or not? If you're an investor and you're picking stocks, are you using a rule that gives you a good long-term return, or that's going to bankrupt you? If you're a mathematician and you are proving a theorem, are you using the rules that give you the right answer? So the beauty of it is that every case can be measured according to the use of the rules relative to a random model, right? That is, you're not using any good rules. So, and then the question is, for me, where do these rules come from? How do we learn them, right? Can you generalize from one rule to another, which would be a kind of a meta-intelligence? So, society, for example, in being racist and sexist, is being stupid, right? It's using a rule, which is, I'm going to use some superficial attribute, your chromosomes, right, or some pigment in your skin cells, as the basis for a political decision, right, or an employment decision. That's manifestly stupid, and so it conforms to the definitions. And why I care about this, by the way, as an ethical research project, is I believe that anyone can acquire rules to make them smart. And that's the other thing I don't like about IQ. It's innatist. It says, here is this coarse-grained quantity that can't tell me the difference between an ant and a sea lion, right? And you were born with it, right? So it's a sort of a double whammy. And the history of the IQ test, as you know, is rather tawdry. But I'm of the school that believes that while we might show differences in the efficiency with which we can acquire rules, right? Some of us might acquire mathematics more quickly than others and so on, you can still acquire them. And there can be pathways of acquisition that might have gone unexplored. And moreover, and this is where it gets really interesting,
Yes.
you can compensate for a bad rule at one level with a great rule at another. And that was the whole basis of Moneyball, right? You say the individuals might not have the best rules, but there's another rule that allows me to aggregate them that makes them better than everyone else.
Yeah.
And that's why I think this is a powerful framework, and that's what I've been trying to work out. I mean, formally, what these rules look like, etc.
Right. So just to play it back to make sure I'm following along.
Yeah.
So now, do you call this, like, if IQ is like sort of a generalized IQ, a GIQ, do you call this a universal IQ, a UIQ, or?
I don't call it any Q because it doesn't reduce to a single scalar, a single real value. What it amounts to, Toby, actually, is our motion through culture is a motion through a rule space. And we acquire and jettison the rules that best serve our interests and the interest of the collective, according to your disposition. And it's a much higher dimensional space that doesn't reduce to a single value.
Well, got it. There seems to be a deep relationship between this sort of like a Turing/Shannon definition of information and this universal intelligence.
So some of the theories that I use to articulate these ideas are information theoretic. Yes.
So why does the universe manifest intelligence?
No, well, that's interesting.
Is it an accident? Is it?
Well, okay, so that's interesting. Because there's another question here, which is life itself.
Right.
What we mean by life, and what's the relation of intelligence to life, and that's a longer conversation over several single malt whiskies. But here it is in a nutshell. Energy, free energy, that we need to live, is not evenly distributed in the universe.
Right.
For example, in our solar system, most of it's concentrated in a giant fusion reactor, the sun. And we need that energy. So how are we going to get it? And we need to internalize rules that allow us to efficiently harvest the energy. So that's the first sense in which it's necessary, because to the extent that living phenomena require energy to grow and reproduce, gaining access to that energy is not always obvious. So a plant, for example, can orient its leaves in such a way that it maximizes the area exposed to photons. And that kind of phototropism is an intelligent response of the plant. If a plant buried itself, it went the wrong way, right? That would be a stupid plant. It wouldn't last very long, right? Yeah. So that's a good example of an intelligence of the plant. And of course, in our societies, the energy that makes a difference becomes more and more competitively isolated and hard to access. So, you can look at the evolution of life through this lens. I mean, if a large ungulate is able to acquire a huge amount of energy by eating grass, which doesn't require huge strategic ingenuity,
right.
A large predator that is conscious of the behavior of the ungulate outsmarts it, literally, and acquires energy vastly more cheaply. In other words, instead of having to graze for 24 hours, I can just nibble you for an hour. Yeah. And so that's the sort of Darwinian picture re-articulated through intelligence and energy flows. And it goes all the way up, of course, to companies, because the information we need is not universally available. And we use our ingenuity to gain access to it, either through espionage, right, or better use of data sets, or better computation with the same data sets. So the story of why is interesting, because on the one hand, it's the why is the competitive nature of life, and the fact that resources are not uniformly distributed, and so everyone is after that finite resource, and ingenuity helps. But the deeper metaphysical question of why that at all? And that's, I think, an unknown, actually. I think that life seeks to represent the world in which it lives, to encode reality. That's what a genome does. That's what a brain does. And the initial impetus towards that kind of reflection of the universe in living matter is not that well understood, I'd say.
It seems dangerously teleological when you say it should.
Yeah, it does sound that way. I think that I think those early stages are difficult. Once it's got going, then it's kind of obvious, right? In other words, once that worm has eaten something for you, then just eat the worm, right? And at that point, we're okay. But at the very, very early stages of this process of ratcheting up intelligence, I think it's difficult. I don't think we have a great answer to that.
Have you done less abstract work on understanding the collective intelligence of organizations, like Jeffrey has done work on understanding the life scale, the lifespan and scale of organizations?
Yeah, so lots of work. So so of course now where does the sort of rubber hit the road, right? And I have worked in many different scales. One that interested me many years ago was in building molecular transistors. So can I build a computer that solves a problem out of proteins in cells as opposed to building them out of hardware? So I did a lot of work on the statistical physics principles of biological computing devices. And okay, so that's one area we could talk about. At a totally different level, and that's a number of us here, Jessica Flagg and Brian Daniels and others, Simon Judeo, we've been looking at how can you interpret society as an intelligence inferential device. And we derived a new theory that we call inductive game theory to try and explain society as if it were a circuit. And this sounds kind of weird, but let me just make it a little bit more concrete. I mean, everyone who's listening to this would be familiar with the idea of a social network, who your friends are and who you speak to professionally, socially. But now think about that as a circuit. So there's information going from Toby to David and David and so on. And you can actually represent that social network as a social circuit. And you can ask, what can it compute? What problems can it solve? And some social networks are terrible at solving problems. They have the wrong structure, the wrong circuit design, and others very good. And we've worked a lot on the structure, if you like, of social circuits and the kinds of things they can compute. And one of the things, incidentally, that we worked on quite a lot was conflict. If you have a certain kind of social circuit, will that produce a very long conflict at a very high amplitude, or would it be very short-lived? And how could you change that circuit so as to change the outcome? And that's something that we've done a great deal of work on, and using real data sets actually globally to try and understand and predict the origin and duration of war.
Do you think there's a possibility that if organizations have a collective intelligence, that we have seen or theoretically should see a type of Flynn effect in organizations and societies as if they are actually good at error correction and they're making hard problems easy, should they actually get more intelligent as they grow and evolve in age?
Well, or they could senesce, of course. I mean, it's a very interesting point. I think that I don't think we have yet the social computation theory of the firm. Most economic models treat the firm as a one-dimensional thing.
Right.
And what you're asking here, I think, is a really interesting question. And to answer that, you'd have to say, okay, we have to reconstruct the circuit of the company. We have to define appropriate actions for individuals in that circuit. Yeah. So in an integrated circuit, it's quite easy, right? Current flows or doesn't flow. This would be more complicated than that. And then ask, what function is it computing? Is it computing it robustly? If I eliminate those units, do we lose the function? If I add those, do I gain a better function? I think that is the future, by the way, of the firm. I feel we need to develop rigorous collective computation theories for organizations. We're doing it for the brain, right? That's called computational neuroscience. It's not familiar to many people. It's familiar to people working in deep learning who use neural nets, right? So, but we don't, for some reason, yet develop comparable models for companies. We could. And we do reconstruct social networks, and many companies offer that service, but they don't go to the next step.
Yeah. What do you think is actually flowing in the network of an organization between these circuits or people? Is it doesn't seem to be just information, or it's information that would be defined slightly differently.
I think it's very hard. And that's why in our case, when we studied warfare, it was quite easy because the thing that we studied was the circulation of aggression.
Right.
Or violent conflict, right? It's very easy to measure. So you can say, within that unit of time, how many conflicts were you involved with, and so on. It's almost as simple as looking at spiking in neurons, right?
Right.
But what you're asking is, how would you quantify ideas and knowledge? What are the right units? And I think we have no idea. I think the place that anyone sensible would begin would be, you'd have to define some metric of tangible outcome. You'd have to say, this person's delivered so many X, or, but without doing that first, I think this entire endeavor would be misguided. I think you're absolutely right. I think understanding what is flowing is absolutely crucial here.
Right. It seems the metabolic requirement for organizations, just from an intuitive perspective, probably take at least 3 characteristics, of which 2 can be fairly regularly measured. So one of them is just, basic energy that you could call cash. Like organizations are good, like they prosper to the extent that they can harvest money. The second one is information. That seems pretty self-evident as well, that organizations work well if they can distribute and harness information. But the third one, because and this points to its organization's collective nature, is, I think, trust. Like an organization stays an organization to the extent that it can trust its membership. All those things seem to be somewhat measurable, but I'm sure those aren't the only things. Do you have any thought on that just rough intuitive model?
Yeah, that's interesting. So what I have seen is the following. You look at a successful organization and you correlate it with a network structure. Right? So you say, look, these ones that are more fully connected, as opposed to less hierarchical, they correlate with, as you say, greater well-being, greater trust, and so on. And that's sort of state of the art. Right? Because you have to get the network measurement right and you have to get the trust measurement right. Yeah. But what we're talking about here is much deeper. We're saying we want to go beyond correlation and we want to measure the flow of something.
Right.
And I am honestly, Toby, not aware of a single study that does it. And I think part of it has to do with I mean, of course, the flow of disease. I mean,
Mhm.
I'm not saying people don't study flow, but the kinds of concepts you're talking about. Information you could do. In other words, you could say, how much do you know about the following 10 things?
Mhm.
And then I've spoken to Toby now. You ask me the question again.
Mhm.
And then I say, okay, I've acquired 6 of those from you. And so you could measure flow through suitable surveys. Trust would be extraordinarily hard.
Mhm.
But I think this is really important, actually, just to get across, by the way, the difference in really good and bad theory. Because, in fact, if you go back to the founding documents of the Institute,
Mhm.
one of the conversations they had, and that Murray was very keen on, was don't prematurely mathematize, right? Get your concepts straight. And I think that's exactly what you're saying. And I think, what do we mean by trust? How do we operationalize it? How do we measure it? I don't do any modeling, no networks, no flows until I get that right. And then we can think about it. And I think it'd be a very interesting project.
I've talked to you before about, I think you called it the 3 M's of mayhem, I believe.
Yes.
There's a distinction between models, mathematics, and metaphor. That sort of seems connected to this idea that don't mathematize until at least you have a working idea of the first 2. Do you see them sequentially, or do you see them as...
Not necessarily. It's. I think in many cases they are. I don't think they have to be. Yeah, I sometimes call this M-cubed mayhem. And that mayhem derives from not knowing which of the 3 we're dealing with.
Right.
And it was our earlier conversation with me being disparaging about, these kinds of theorists of the firm,
Yes.
who pretend to be in the domain of models and math, but actually are in the domain of metaphor.
Right.
And I think there's nothing wrong at all with metaphor. It's exquisite. It's just that it behooves us to know which one we're in, right?
Yeah.
Because they come with different affordances and capabilities.
Right.
So, yeah, I think it depends on the problem, as you pointed out. I mean, you go to the success of reductionism.
Mm-hmm.
Newton, it's an interesting question. I mean, but he was pretty fast to the mathematics.
Right.
He didn't need to mess around too much with metaphor. You could argue historically others did, and he benefited from that, which might be true. I think it depends on the problem. I find in my own work, for example, that I'll give you an example. So there's a paper that we just finished, and it's on the cyclicity of institutions, why things come into existence and why they disappear. Mm-hmm. And I'm particularly interested in scientific revolutions, why ideas last beyond their sell-by date, right? Which is true for many things, including me probably. So, but that formalizing that model was very hard for me. Huh. And so I had to start with visual metaphors. Okay. And, what is this object which I need to mathematize? I can't see it yet. I didn't know what the equations were because I didn't know what the problem was. And so I use historical metaphors. I was thinking, well, okay. So Thomas Kuhn wrote a very famous book on scientific revolutions, and he talked about periods of normal science and revolutionary science. Now, these are metaphors. I mean, there's no math there. I say, okay. So, okay, normal science and revolutionary science. Okay. So what would that be in a model? Right? Well, normal science looks like the transmission of an existing idea without change. Okay, that looks like. And revolutionary science looks like throwing that out, right, and starting again. Right. Okay, so how would I mathematize that? So that's exactly to your point. That was the sequence there. I couldn't see my way into the model without the historical metaphor. There are other problems I've worked on, though. Like now, for example, a model on optimal learning, where you have a noisy data set and you want to track the environment efficiently. I don't need metaphors. Right. In other words, I kind of know what that looks like. Right. And you could be right historically in the sense it could simply be that I'm so familiar with the latter that I knew where to go. Right. whereas in the former, I had to sort of use that more subjective framing.
That's interesting because it may be very personal. Like if you already have a concretized metaphor in your head, maybe you don't require the articulation of one out loud.
Exactly.
I just had a lovely conversation with Wendy Carlin, who will be, I think, one of my next guests. And she gave this great presentation with Sam Bowles, who I'm sure you saw it, and it was explicitly about the narrative of
yes,
and an emerging new paradigm with an emerging new narrative. And one of the things we talked about is, potentially this is the death of neoliberalism, and neoliberalism has a metaphorical and a narrative structure. Like we can all point to it. And if there's an emerging paradigm, what's its name, and is that important? And she thought it was important that this new way had a name, and it would have a credo, and it would have a one sentence description, and it would have a archetypal story. And do you think that is probably important for economics, which is publicly consumed? But is it important for some of the basic science that you do as well?
Yeah, I think it's really a deep issue. Some of my early work in the 90s was developing what we called then evolutionary language games, which was the mathematical game theoretic approach to language evolution, and based actually on Wittgenstein's concept of the language game.
Right.
And again, that's kind of a deep issue, and the basic question there is, let's say that we are both confronted with a continuous reality. It's not a discrete reality.
Right.
Color is a good example, right? It's just a continuous electromagnetic spectrum, but we still have red and orange and green and so on. And so you have to carve up the continuum, and you have to share it and know that you're pointing to the same frequency. So there's what in game theory is called the coordination problem. Okay. And in order to solve certain cooperative tasks, you had to invent linguistic categories which are false because reality is continuous.
Right.
But to coordinate, we needed to do it. And I think that's the sense in which I believe in the value of the narrative. I believe the narrative might be important as a coordination mechanism in society.
Sure.
But we shouldn't confuse it with reality. And I think what happens, which is the problem of normality, and loss aversion, etc., is that we actually confuse those language games for reality and cleave to them.
Right.
So somehow you have to build into your narrative a half-life, that says, it's going to kind of expire at a certain point.
You should know that when you invoke Wittgenstein, the two people who are currently listening dial out. That's probably the podcast maxim. we just lost our that is fascinating. So, back to potentially more practical matters. You run an organization yourself. You're an organizational man. Mm-hmm. I called you the maverick scientist leader. So you're balancing a bunch of different things there. An observation I've had is that the way SFI is structured, and I'd like you to talk a little bit about that, is potentially the way many organizations will be structured in the future. You want to just let us into how SFI is structured?
Yeah. So SFI balances a distributed network of affiliated researchers with physical loci, and there are two of them in Santa Fe. Yeah. And that's important, incidentally. Physical space matters, but it matters less than we have assumed it matters, right? So we fetishized it. But it matters. So I think one wants to be pluralistic about this. So the Institute we don't have tenure, of course, and we don't have disciplines and departments. We jettisoned those right from the beginning. So we're very sort of problem-centric, not department-centric. Okay. And we realized that to do that, we needed a network of individuals who had complementary insights, and we had to find a way of integrating them. And so are faculty all over the world, more or less in every continent, at universities and research institutes and companies. And we bring them together at the physical space to discuss problems. But of course, many of the solutions are provided off-site, right? So the Institute is much larger than it would appear if you visited it. I mean, everyone has stories to tell about it because it's kind of a famous place, and people visit and they say, well, this is great. This is obviously the outhouse. You know? And you say, no, that's it. And so we're not one of those big, edifice complex type of institutes. We live in beautiful, small, as you know well, Toby, adobe houses, which are appropriate for life on Arrakis, Dune reference there for nerds, and beautiful mud buildings that are human and humanizing, that people from all over the world like to come and work in. And so, okay, now yes.
Just to interrupt, if you are also, I should point this out, if you're just a cynical operator and you care about the bottom line, I must say it's an ingenious way to get hundreds, if not thousands, of the brightest minds in the world that you don't have to pay for necessarily.
That's true, but there's some really, you're absolutely right, but here's the key point. That's absolutely true. So again, just to clarify for everybody, most of those affiliated faculty are not on our payroll. They're on Harvard's payroll or Yale or Cambridge or whatever payroll. Okay. The key is that their intellectual and emotional vectors align with ours.
Right.
We as an institute in the collective will enable their mission, often more so than their home institution. Not always, but very often. And so your attachment, actually, and this has actually been the great success of the Institute, is not to the person who pays you, but the person who allows you to realize who you are.
Right.
And you're right. But it's quite sincere, and I think it's real. And my job, in part, when you talk about leadership, is to make that true. Right? In other words, if Toby at Shopify said, "Look, I'm paid here, but everything I deeply care about is at the Institute. Help me realize my ambition," because it's not being realized at Shopify. I hasten to add that's a thought experiment. But if that were true, that would be a true alliance.
Yes.
And so I work very hard to make that true.
It is like, again, I think there's something in that. Like, I think that is a metaphor for how humans are going to relate to organizations in the future. Just imagine when, potentially there's a universal basic income, many of your needs would be met. Where do you actually find this sort of intellectual and emotional juice in the world? And I see this sort of loose affiliation of like-minded people being the organization of the future, not just scientifically, but in all aspects of life.
No, I think it has been true in a way. I mean, people have that affiliation to a city, for example, or to a nation. We call it patriotism. To their reading groups, to their sports clubs. You can support the Chicago Bulls, but they sure as hell don't pay you, right? I mean, they don't pay many people, but it can be your entire life, your commitment to a sports team. Mm-hmm. And we are exactly in that business. We want to be your life of the mind.
Yes.
Right. So with respect to your ideas, and of course that means we're very selective because it is a scarce resource, the Institute. And we pick our affiliated researchers extremely carefully, with very high standards, we hope. Mm-hmm. And so it's not a demotic populist institute by any means. We serve the world intellectually as a sports team serves its fans, but not everyone can play for the team. Yeah. And I think understanding that duality is critical to the success of an organization like ours.
That's fascinating. You talk about just the structure again of the organization. You talked about growing the graph versus growing.
Yes.
Can you just dive into what that means You're sort of recapping some of the things we talked about. But
yes, yeah, sure. So because of this emphasis we have on adaptive reality, very broadly construed, right, at many scales, the way in which we think about building the organization is different. So, and I make this distinction between growing the vertex versus growing the graph, okay? Now, just for everyone to understand, a vertex is just, if you look at a graph or a network, perhaps more familiar, you have edges or lines connecting circles, and those are called nodes or vertices. And so let's say a university or a cancer research institute or a climate research institute or a poverty research institute focuses on its area of expertise and attracts to itself more and more people with that expertise.
Right.
So it's essentially a clonal organization with minor variations and great depth. That's growing the node or growing the vertex, right? And that's what a department is. It's the standard model of knowledge production in the history of our civilizations. But you can do it differently. You can say, instead of digging deeper and deeper, I want to extend a connection to a very distant area of inquiry, which when combined with mine will produce extraordinary synergies. And a good example would be neural networks and machine learning, right? You say, I want to solve AI type problems in a very circumscribed way, and I'm going to connect to this domain of neural networks. And all of a sudden you get things that can win Go and not do much else, but everyone gets excited about them. Okay, what have you. So that I call growing the graph. And for the Santa Fe Institute, that is my strategic value, right? In other words, what do I do in a position of leadership beyond being a mascot, right? And I'm not a very good one. I'm not even cute, you know, I'm not cuddly enough to be a mascot. And so I suspect that the value is that I'm always looking around the landscape of ideas and asking myself, in this domain, for this problem, what's missing? What don't we have? What element could we combine with existing elements so as to address it more faithfully or more effectively? And that's growing the graph. And that's, by the way, the history of mathematics, connecting different areas of inquiry. They're both complementary, right? In other words, it's not us versus them. It's not, both are important. It's just that the places that grow grass versus growing nodes, right, are measure zero. There aren't any.
Right.
Companies might, and it's something that you've pointed out, but in the area of research, a typical career is more and more narrow focus.
Right. And this goes back to where we started with reductionism on one side, complexity on the other, depth on the side of reductionism, breadth on the side of complexity. So do you see your job primarily as one of selection, arbitration, and connection? Is that the sort of the emerging prototype of the new leader?
Well, I can't comment on the latter, but I will say that I take our science seriously in my job. In other words, and this is an odd thing to say, right? You could say, let's just consider the difference between my job and the CEO of a shoe company, okay? Now, you make the most amazing sports shoes in the world and everyone wants to own them. But the production of shoes doesn't lead necessarily to ideas and insights that make you better as a CEO, right? In other words, you have to know your market, but there's not something about the lace, for example, or the sole that gives you a competitive edge over someone else. Now, in my world, it's very different, and it's actually a rather lucky coincidence because we live in a networked world where ideas rule, by and large, and where novelty in ideas is highly prized. The Santa Fe Institute studies networks of agents that generate ideas, right? And that adapt to prevailing conditions. So ideas of evolvability, adaptability, robustness, right? Network structure, scaling. The ideas that we work on actually work for the institute itself.
Right.
And that's, and so to that point, so I'm very, very aware of that alignment. And I think that's extremely rare. I can't actually think of many other places where that's true. Maybe it's true in your company. But so my bread and butter as a scientist is my bread and butter as a leader. Do you know what I mean?
I do.
And that's really useful. And so I do sit down and ask that. I say, is the institute robust? Is it becoming sclerotic? Is it evolvable? What are our adjacencies? Who are people that will extend the graph? And so on. And so, yes, I think I don't know if that's the model of the leader of the future, but it's certainly the model that I follow.
Right. It seems like there would almost be like an algebraic equation, like some formula that would say, actually, the next area of inquiry is X, given that the idea space is this broad and this is where we're deficient. I'm sure you do that by intuition, but
you know, it's interesting. We have looked at things like that actually, and we have looked at the networks of knowledge to see where there's density and sparsity, and as of yet, turning that into a decision is hard. Right? So
obviously, like, is it? You know, it's always like AI or big data. Like, is that? And so.
But we don't do that. Okay, so here's a very important distinction for us, and as you know, and for people listening might not. I know Toby pretty well, and he's on our board, so he comes to board meetings, and and one of the things that as a someone in my position, people will often get very excited about the latest thing. So why is SFI not doing more machine learning? You need to do that. Why aren't you doing healthcare? And my argument is always, you're missing the point, right? Which is that SFI is this very interesting Lego kit. And my job is to keep as many useful Lego parts in place that we can build almost any cool structure. And what I don't want to do is replace all my parts with the one part that would make me great as a cancer research institute. Because in 2 years' time, another trustee will be saying, David, you know, why aren't you working on supply chain management or what have you? And we'd be stuck. And I think, again, it's one of the great privileges of being this mercurial organization that's doing fundamental science, which is that we don't have to commit to one problem. The second point I would like to make, and this is maybe harder for people to grasp, is that there is a family resemblance amongst all those structures that you can build out of Lego. Right. And there are theories for those general structures. And that we call universality. And that can be super useful too. And I think scaling theory is a beautiful example. That was exactly one of these universal theories that turns out to be useful, but it wasn't a Lego bit. It was actually the recognition that many of these structures showed architectural commonalities. And so you can theorize at that level too. So it's kind of neat that you can play both the modular assembly kit game and the generalized theory game at the same time.
Right. Yeah. So just a couple of practical questions before I let you go. One is you touched on the utility of physical space. And so this idea that there is a exodus to SFI. It is like a pilgrimage, rather, that people take, and it feels that way. It's a Santa Fe is a tertiary city. It's difficult to get to. It's painful. When I'm there with board members, there's always grumbling. But I also think that's part of its genius, that you're sort of cloistered and stuck there. My suspicion is more and more organizations are going to resemble that, at least for the next couple of years when travel is not as frequent. Do you have a heuristic about how?
Yes. Yeah. Well, as I've thought about this a lot, and of course, as you know, I have I tend to think in threes. I'm not quite sure why, but about everything. And I have this metaphor.
Templar knighted.
It is, but I kind of think of it as Charles Persian myself. And that is that I have the metaphor of, the mountain, the monastery, and the metropolis. And that is how I think about places. And think about the following workflow. You need some time alone to really think broadly without the constraints of society. Metaphorically, you go into the mountains. Now, that could be many different things for people. I mean, that could be a swimming pool in a city. I don't mean to be restrictive, but it means isolation and solitude, etc. At a certain point, once you've reached some kind of conclusion in your own mind, you need to share that with a society that is tolerant of a diversity of opinions and supportive. That's called a monastery. Basically, people in that monastery are not there to knock you down. They're there to refine your beliefs and practices. And once they've reached maturity in the monastery, you can move into the metropolis where people are going to stab the shit out of you. Okay. And so, and that's a cutthroat environment, but by now you're confident that you've learned your martial art, right? Okay. And what I found in my career was that people tried unsuccessfully to combine them all. So they would say, we're going to build the ultimate work environment. And so you build these ridiculous structures. It's in a forest. It sort of looks like, what is this? It's wilderness. Is this a monastery? What is this thing? And usually they're terrible. And they look beautiful on the architectural plans, but once someone moves into them, they feel wrong. And what I've come to realize is SFI is a monastery in the mountains.
Right.
And we're best at that, right? If you want to come out here and for some solitude to think, we've got the mountains, and then you can come and join us, and we're going to support you. But we're not the metropolis. And so we're not the place that's going to scale up that idea. We're not the place that's going to profit from that idea, actually. It's not what we do. Yeah. And what we rely on is a few of our sort of itinerant monks having made it in the world, coming back and building a new chapel. Right? In other words, that is how we work. And I feel very strongly about that, is that we shouldn't blend those together. We should allow them to live separately, and we should allow individuals, all of us, to experience all three environments. And I don't think we do that very well, actually.
Do you think that could be a blueprint for other organizations, not just Santa Fe?
I think it is, in a way, and I think the ones that are honest, the good ones that are honest, will say, we are a monastery in a metropolis, right? Or we are a metropolis if you're Harvard or something, and so or Arizona State. So the bad ones kind of want their cake and eat it, right? They're trying to be everything they can't be,
right.
And rather than say it's a model for it's a model for respecting the creative life of the individual. Right. That's how I like to think about it.
That's interesting. Oh, as you know, I went to the mountain for a month and lived as a monk of some type, and I found that my corporate life was completely recharged when I returned to the metropolis. So there's probably very practical lessons we can learn from that, even if you're not a researcher.
Oh, absolutely. I think this is about human need. And we all need solitude, and we all need society. And I think that SFI is just self-aware of where it lives in that sort of life path, right? It's sort of, yes, we're the monastery, and we're a secular monastery, of course, a scientific one. But in many other respects, we're quite comparable to the kinds of places you would find in the mountains of Tibet.
Sure. Although I didn't get much support from you at SFI and others. I think there was a bet going that I would spend my entire time in the mountains in the pub drinking. I remember.
No, I mean, you have to come back and, and the abbot treats you with this sort of healthy dose of skeptical respect, you know.
Yeah. Speaking of abbots, there's a series of A's. You could be in the Airy with an abbot with its acolytes and the agora. You could have.
Oh, nice! I like the alliterative approach.
Yes.
Nice.
Well, you went M's.
I went M's. You go A's. That's great.
Okay. The last sort of practical question, and we haven't. I don't know if I've even talked to you about this, but I've your ideas of cognitive artifacts and ones that can be helpful and ones that can be sort of detrimental to our function. Do you want to just take us?
Yeah. So one of the, again, this gets to my research, and so in the area of collective computation, it doesn't just have to be swarms, right? Which is lots of the same type of thing, like lots of birds or lots of humans. It can be hybrid.
Right.
So you can have a collective of humans and computers and slide rules and pens and paper.
Right.
And pianos and so on. And so I've been very interested in collective computation in the hybrid setting.
Right.
And we don't, again, this is really interesting because we have very bad theory here. And we actually don't have any. We have a user interface design. There are these fields that have grown up as sort of soft sciences around humans and non-human artifacts. Mm-hmm. But there's no theory of intelligence which integrates the two, and that's what I've been trying to work on. And if you start doing that, you realize something quite interesting quite quickly, and that is that you can categorize artifacts as falling into two broad categories. And I call one essentially a competitive artifact, mm-hmm. and the other one, in different languages, you can call a cooperative artifact. And let me just give you an example of each. A map. Now, a map is a really useful thing. The collective can contribute to it because we haven't experienced the entire territory ourselves, but as a collective we might have. But the collective, having recorded the map extrinsically on paper, an individual mind can then internalize it. And the beautiful thing about a map is, having seen it and pored over it for sufficient time, you can now dispose of it and have it in your mind's eye. Yeah. Okay. That's clearly an extraordinary device, and it's a cooperative artifact. Now,
just to make sure I'm following, it's cooperative because it's cooperating with your own function, or it's cooperating with others like you who have helped to build it?
The former, meaning that it's cooperating with the way your brain works, because if I take it away, you're better without it than you were before, right? In other words, you might be better with it in totality, mm-hmm. but when I take it away, there's nothing there. There's still an imprint of the map in some form. And this will become clearer when I consider competitive artifacts. Think about your navigation system in a vehicle. Mm-hmm. Now, your navigation system in a vehicle tells you where to drive, completely relieving you of any responsibility for having spatial awareness of your environment. Right. And if I take away from you your navigation equipment, you're actually worse than you were, very probably, than before you started using it, because you've grown so dependent on it. Another example would be an abacus versus a calculator. If you learn how to use an abacus very proficiently, you can actually remove the abacus, and you have an internal model of an abacus. It's a very well-known effect. It's called the mental abacus. But with a calculator, it doesn't matter how many sums you produce, you never get any better at them. Okay.
And David, just before is that because of the tactility of the tool?
No. It's actually quite interesting. Okay, it comes down to a principle that I call transparency, which is,
I see where we're going.
You see, if an abacus, the mechanics of the device are available to you. Right. Mm-hmm. And when you encode the abacus, you don't encode the solutions, you encode the mechanics. Right. With a calculator, which is basically just an input-output device, as far as we're concerned, the mechanics are completely inscrutable and opaque. And so you can't learn anything about the mechanics. You just learn the paired numbers at best.
So
And
just to play back your theory,
yes.
If intelligence is making hard problems easy, the abacus is actually making transparent how that happens. So that the code, if you will, of making that particular problem easy is now transparent to you. You see it, thus you learn it.
Exactly. In fact, this is why this matters. That's exactly right. Because what cognitive artifacts are that are cooperative is at the ultimate intelligence amplifiers.
Right.
Because they're the devices that culture has discovered that provide a learning scaffold for you to acquire very difficult skills or rules. That's exactly right. And you can actually look at the evolution of culture through the lens of these two artifacts. And historically, cooperative artifacts dominated mechanical transparency. And increasingly, we're building toasters, right, gadgets, that make the internal mechanics invisible for proprietary reasons often, harming, I think, the learning and human intelligence. And so I think this actually matters. And this is obviously an area that I've discussed many times. And I hear all these people waffling on about singularities and AIs that are going to take over the world and turn us into batteries. And, and we need kill switches. And I don't give a shit about any of that. What I really care about is the human brain diminishing because the physical environment is insufficiently populated with cooperative cognitive artifacts. And language is a beautiful example of one, right? Mathematics, culture, artistic practices. I mean, you can start, once you look at the world through this lens, you can sort of see, and you can see what's happening with all of our apps, right? Which I call, by the way, AI, right? Which is not the AI that other people have in mind, which is essentially removing the learning scaffold. Now, it doesn't mean, by the way, that you would be worse off if you had it, because, of course, in a world when you always have access to your apps, you perform just fine. But you are diminished as a cognitive element, as a cognitive being.
So interesting, just to segue to the end here. Do you think there's a relationship between that theory and, what many people would describe as the potential end to our culture and civilization? We have, 40 million people unemployed in the U.S., riots in the street. Is some part of that a sort of civilizational or cultural amnesia of how we built the organization, the very complex society that we're in? Many people don't know how it's built, don't know its laws, its rules, its culture, its history, for example. Is this contributing to this sort of malaise?
I think it must. It must. I think that the purpose of education is to make everyone smarter. I very firmly believe in that. And there hasn't been as much progress in developing these cognitive artifacts as I would have hoped. Of course, the expediency of economics and the market drive us towards this alternative approach where people become operators of artifacts rather than collaborators. And so it's hard for me to imagine that's not true. I don't know. I don't have any data to suggest it's true, but it seems to be very plausible. And it would be easy to be disenfranchised if you didn't understand how the political machine worked. You wouldn't know how to operate it. You wouldn't know how to game it, for example. And so I think you're absolutely right. I think this notion of cognitive transparency, I very strongly believe in. I think you have to give everyone X-ray specs to see through complex machines. And that's why I'm such a fan, by the way, of games like Minecraft, where you allow kids to co-construct reality. I mean, they learn the rules for building things. And I think there's a huge amount in that domain that we could be thinking carefully about.
Right. So, given these uncertain and turbulent times, let's end on a note of optimism. What can potentially get better and why?
Everything. Everything. No, I really believe that, actually.
Yeah.
I think that's what's so frightening, right? It gets to my point about normal science versus revolutionary science and inertia, and the forces of change versus the forces of stasis.
Mm-hmm.
And there isn't one domain of activity where we couldn't sit down for 5 minutes and propose a better alternative.
No.
I really believe it. And I think that you then have to answer the question, so why hasn't that happened? And I think there are just too many vested interests. There's just too many reasons not to. And unfortunately, the discretionary power is very unevenly distributed in terms of, instrumental power. And I think we've had enough of that as a society. And I think democratizing everyone's ability to contribute to the structure of the world would be tremendous.
Mm-hmm. One of the things history teaches that pandemics are often revelatory in that they reveal the real structure. To your point about cognitive transparency, and to the point that things can get better, I think that everyone is actually realizing how things actually work now. Like what is essential now? What that word has played out over and over again. So potentially we can share your optimism that with cognitive transparency, the whole world can be transformed for the better. So
I will just add, if the Institute could make accessible without excessive dilution these tools and frameworks,
right. I
genuinely believe that they would be the groundwork for a new society.
Yes. Well, that's lovely and noble sentiment, and one that I back 100%. So thanks, David, for your time. Always enjoyable, lovely, and fun. So.
That's fun. I wonder how you're going to make sense of all of this, Toby. That's going to be great.
Just going to throw it out there and let that be the problem of others.
Yeah, let other people worry about that. That's great. Well, anyway, it was wonderful seeing you. A great chat, and we'll catch up soon.
Cheers, David.
Bye-bye. All right, bye.